Hey, thanks for joining the channel. Good to see you again. Hope you're all well. Today on the bench, I might have something that's familiar to some of you. It's just a Pioneer SX-440 stereo receiver. It's in pretty minty condition. It's very nice. This was brought by a client. He wants the full gamble, switches, pots, lamps. He even supplied me with some LEDs he wants to install, so we're going to do that. Go through and replace caps, get this thing working 100%. We don't know. I don't know what it does or doesn't do right now. I think it does work, but it's got those goofy connectors on the back for the speakers, and I couldn't be bothered to figure out to connect speakers up. So maybe I'll take the lid off and use some alligator clips. That might be the easy solution for me right now, because like I said, I couldn't be bothered. But let's plug it in and try it. I think it does do everything it's supposed to do. Let's turn this thing on. Ooh. I went up to about 15 watts, now it's down around 10. I can hear kind of a loud humming coming from inside. A noisy power transformer. And we are greeted with two lamps that are working. I don't know if on the dial pointer is working, but aside from that, everything. So we're going to get into this. It's not a heavyweight like guys like to see, but we'll do what we can for this thing. Let's get the top off, have a look inside. So it does have a real wood veneer. This looks like maple, or not maple, walnut. And I think the owner has plans for this cabinet. I think he might be refinishing it or building a new one, I'm not sure. But you can see it's got some fading on the right hand side, left hand side. Used to be a sticker here, this is all faded. That's more of the original color. And it's fairly good. It's got a few scratches on it, but this side here has something going on too. And then the underside is painted black. And look at this thing. This reminds me of the early Harman Kardons, where they got a chassis, printed circuit boards mounted to it. Lots of stuff going on here. Very interesting design. So yes, I'll be replacing all these caps with new ones. They're probably done by now. And looks like we have a little power supply over here, a little cute little power supply. Power transformer, these two SD 130s. I don't know if these are regulators or output devices. I don't think they are output devices. This looks like audio tone control. This is all tuner back here, AM, FM. Let's take the bottom off as well. So I guess these are output devices. There's there's four of these 2SD 130s TO66 devices. It looks like they're glued down with some kind of a clear silicone or something. I think they're bonded to, they have the insulator and then they're bonded. So that must be our quasi-complementary output. I don't see any big capacitors. They might be underneath if there's capacitor coupled. There might be a couple of big caps underneath for that, but this looks like pretty standard affair. First look at the bottom. Kind of a cool effect. And look at this. Oh yeah. These are all the businesses right here. So these might be our output device, capacitors. 1000 microfarad. The amplifier is all over here. Yeah, this is capacitor coupled. Interesting. So it's easy to get access for servicing pots and switches. So I'll get busy doing a recap. We'll get started on that, and then we'll work through and see if there's any problems. One of the things the owner wanted me to do is replace these goofy connectors with something that's more friendly. There really isn't, he gave me these binding posts, but there really isn't any room here to put a set of 4 and 4. That would not work. You would not be able to turn them. They're too close together. I do have a solution though. It might make some of you people groan, but I pulled this connector off of an old Sony, and it looks like it'll fit right here, and that'll provide at least an area where you can put wires in. And I could do one of those this way, and then leave the other one stock, and I think that's what I'm going to end up doing here on this. This should fit and provide you with something to connect to. But let me connect a pair of speakers and turn this thing on, see what kind of sound it makes. I have a feeling it's working pretty good. I don't see anybody doing any work in here. It looks like it's all virgin, untouched. Everything in the power amp looks untouched. Hopefully we won't have to touch anything here. Just go ahead and replace caps and be done with it. Okay, so I got it connected to power and speakers. Let's try it out. Greeted with a thump. That's typical of capacitor coupled outputs. Auxiliary here. Tone on both sides. Right. Left. Phono stage. It's fairly quiet. FM stereo. It's got no antenna, but it's still picking up stations, and it is picking up stereo. Stereo signal. This tuner's working okay. AM.
You know, I was writing young adult novels. I was writing about teenagers, and I was like 25 at the time, so it kind of felt like that.
I don't know what that noise is. I think I got some stuff going on here on the bench. It might be just interference. Looks like all the switches and pots are already tuned up for me. Everything's working good. It's a fully functioning receiver. So let's just do our best and see if we can make it sound a little better with a fresh set of caps. Maybe I'd do some tests on it, maybe. I don't know. I don't know if I could take the time to do tests before and after. Now, I think I'm just going to go start with the recap, and because I'm kind of short on time here, so let's just do this. Anytime a unit comes in like this, I like checking what was in the fuse holders. It's always surprising. Oh look, this is a 10 amp fuse. Is that right? 10 amp? It's supposed to be 1 amp. Yeah, that says 10. That's a fail. What's this here? These are protection fuses, 1 amp each. Left is... oh, that's a 5 amp. That's an automotive fuse, 32 volt. That's no good. Right channel. Oh, 4 amp, 32 volts. Another fail. So we're going to need some fuses for this thing. I always feel bad when I do recapping on this vintage gear because look at this capacitor. This is a 220 microfarad at 25 volt. Look at its modern equivalent. The size difference here. You put these little microscopic caps on the board, it just kind of loses its presence. But it's got to be done. Like these caps, you just can't keep running with them because, you know, I'm gonna guess that a certain percentage of these have already failed. But you know, you probably might have 80% of the caps are still good, but that's still not good enough. You got to have 100% of your caps working. So I'm gonna go through and do this, and this is going to be a little difficult. This little power board here, I have 4 or 5 caps, 3 caps I think, and it's all buried underneath these two output capacitors. So I'll have to disconnect these, move them out of the way, do my repairs or retrofit, and then put them back. Yeah, but it has to be done. Okay, so I finished the recap up to this point. I'm still sitting on the fence about this cap. I think I just might leave it in place and put a another cap under here. I'm going to upsize it. I'm going to double it in size, 2200. And I think I'm just going to add a terminal strip here underneath beside the old cap and just connect it in. I don't think it'll look out of place. And then I need to figure this out because all I have is radial caps for this. I might have to get creative here. Put a 5 lug terminal strip, and then I can use that for both power and, yeah, I'll have to do something. This, I was looking at this ground system, I was just shaking my head. This is not the way to do it. You don't daisy chain your grounds. This should be all star ground. And I think they're using the center pin here of this terminal strip as your star ground because it seems that's where everything's terminating. But they're also, I don't know, they're using grounds everywhere. So I think I might redo this. You don't want to have current flowing through another wire because any voltage drop on this wire will get induced into this wire as well. So you affect both power supplies. I don't know what these taps are for, but they should be star. Okay, I'll get busy. Yeah, put a 5 strip under here. Okay, it's update time. So I finished recapping this receiver. Very uneventful, not much going on. I said I would leave this cap in place just for cosmetics, and that's where it stays. It's disconnected. What I've done is I disconnected it and I put a 5-pin terminal strip here, and that allowed me to connect the 2 output blocking capacitors for speakers, one here and one here, instead of having these across here like this. I used the terminal strip and ran wire up. That freed up this area here, so now you have access to this little printed circuit board, power supply, to do service if you need to. And another thing, it gave me 2 extra lugs here that I can put this capacitor in place. I just removed the wires from the 1000 microfarad and put it on here, and this is a 2200 microfarad 50 volt, so double the capacitance, and it just fits right underneath there and it's tucked away. Now I did talk to the owner about replacing these goofy speaker connectors, and he's okay with one of these. Actually, it's when you put it in here, it actually looks pretty good. It gives it a good area to connect to. Now I wanted to do this without butchering the back panel at all. No drilling, no holes, no cutting. Like he came back with an option of putting some of these in, and there would be no way to get it unless I butchered this open and put a panel in here and put these on. You wouldn't be able to fit 8 of these connectors on this little area. These are quite big, so I'll return these to him and he can use them somewhere else. And I think this is a good solution right with that. So I did a couple of things yesterday to help this move along. I cut this piece. This is just a mask, and this fits over here like so, just to give it a finished look, because when I put it on in the hole, you see the mask, instead of, there was some light shining through here and it wasn't quite the same size as there. So that mask is just to give it a black background, just to fill that in. And I also cut a piece of insulating sheet just to cover the back of the connector, like that, just to protect these pins. Now these pins are going to interfere with the bottom of the chassis, so I'm going to have to cut them off because they protrude too far, and I'm going to have to make my wire connections directly to the back here. So the wires will come in, they'll go directly to these 4 conductors. This will go on top, it'll all be covered over. And I created this steel plate. This is 3mm steel plate. I drilled, cut it to the right size and drilled a couple holes. So this gets put on the back, and there will be 2 screws to hold this plate onto the connector. Okay, and I might have to trim some of my insulators, but these 2 holes here will line up with the back panel, and that's what I'll use for my mounting. So it all should be sandwiched in like this when it's done, and it should work pretty good. Let me get started with this. One thing the owner requested is to not toss this in the garbage. He wants to save this in case anybody in the future wants to put it back to factory. So I'll take this off, I'll wrap it up, and I'll tuck it away somewhere in the bottom chassis here and tie it down so that it won't rattle around. And it'll be with the receiver. And if anybody ever wanted to go back in time and put these goofy connectors on, they can. It's up to them. They can remove my work and put the original factory back on. So I'll do that as well. Another thing I'm going to have to do is, I don't know, I'm looking at this receiver, and this daisy chain ground they have going here is a joke. One ground here comes off the chassis. This ground goes to the tuner board. This ground goes to speaker output 1, and then it daisy chains through to speaker output 2. These 2 should actually come from the star ground, but there really isn't a star ground on this receiver. It's just a massive black wires connecting anywhere they can. So it's not a huge deal with a low power receiver like this, but it is something to keep in mind, that you should always have a star ground on your audio equipment, audio amplifiers, receivers, just to keep any hum and anything else down. So I'm going to go ahead and get this wired in. They have it right, left, which right is on the left hand side, so I'll probably wire this the same so that the right is on the left hand side and the left is on the right hand side, which is kind of backwards. But we'll get through. I'll get this installed. That's pretty much all the work I need to do to finish this off. The next step will be lamps. I have to do relamping. I've got these lamps to change, the dial indicator lamp, and I think we're going to be pretty much finished. So let me get started on this. Okay, here's one last look at it before I bolt it in. And so it's got the backing plate and standoffs already. It's got the insulating sheet in there. The connections are made inside, and I cut off the ones on top here so there's no chance of it shorting out. So this will go right in. This will go right in. Actually, the wires are a little short, but one thing I need to do is I need to put that on, and I need to trim out the area where the screw will go, just on these 2 corners, and then we can bolt it in. Alright, so this was going to look like installed. It's already mounted, secure. Now I did run into a problem here. This bottom plate screw is going to run into the plastic, so I have to take this out again and dig out some of that plastic in behind there, just so that screw is able to bottom out. And I think that's all I need to do. I need to connect up the ground wire. Speakers are connected. Everything looks good. So yeah, I'll get that, take that little piece of plastic out of there, and then I'll wire up this ground, and we'll be done. Okay, one of the last things I need to do is the lamps. Now these were bought online at hifiaudio.com. Oh, you can't even see it. Here it is. hifiaudio.com. Captain Fantastic 0077 at Gmail. Yeah, so we're going to put these in and see how they look. Get rid of the staple. Before I stab my hand. Now they gave me an extra bulb here. I don't know, extra 2 bulbs. I don't know what they're doing with that. But these are the little LED lamps. And these just pull out, let's see here, with a pair of pliers. You just pull these out, you break the paint. There's paint holding it on. I don't know if that matters. And we just install our new one. What? For some reason it doesn't want to go in. It only goes. Okay. This is protruding a lot farther here, so it doesn't screw in as far as the other one did. So we'll just put that there. I hope it doesn't bottom out and hit something inside. Pretty simple stuff you can do yourself. And then I'll do the dial indicator lamp as well. I'm going to have to heat up the soldering iron for that one. Oh, that's no good. That broke off. Look at that. That rivet broke, the brass rivet. Okay, so what am I going to do in that situation? I'm going to see if I have another holder. I don't think I do. That's the danger of doing this stuff. I didn't really pull on it, I pulled on the base of it. I might have to, might have to figure something out for that one. Okay, leave that one out. This one's in tight. There she goes. Yeah, these bulb holders are not the best quality. Okay. This one back. And we have this one here. This one's tight. I think there's a way I can pry this out. There we go. Probably could have changed it without pulling the socket out, but okay. we got one bum socket. Okay, so, and we have an LED here. This is for the dial indicator, I'm assuming. It's got an LED with a resistor built in. So it should be just wire it up, plug and play. I don't know what color, this is probably white. It's a frosted LED, so I can't see what color it is, but I'm assuming it's white. And they gave us a bulb. I don't know what this is for. 6-volt warm white. Okay. Let's see how this looks so far. Plug it in. Okay, here we go. Turning it on. Well, you know what? I have no fuse in the back. Give me a second. So I got a 1 amp fuse. Put it in the back here without electrocuting myself. You gotta be careful with fuses because when you pull them out, could be live exposed parts. Should be doing this with it unplugged, but okay. Here we go. So we have all these lamps on. They're all working. You can see this one's strobing. So that's what it's going to look like. We have to get our fourth lamp going here. Doesn't look very even. You got bright, dim, bright, dim, bright, dim. There should be more diffusing in there. I think with incandescent bulbs you get more of an even light because it's one point source of light. Not if you look at this bulb or this replacement, you have one LED here that's shining light forward, and then you have 4 LEDs that are shining light sideways. This one here is the one that's causing this bright spot because it's shining directly onto the filter. It's really not ideal, but you put a incandescent, you get that source and it evens it out more instead of being all pointed in one direction. So let me fix this this lamp holder here. I don't know what I'm going to do about it. I'll see if I have any in stock, and if I don't, I'll see if I can fix this one up. Okay, I looked. I don't have any of these lamp bases. These are called E10 lamp bases, by the way. 10 being the diameter, I'm assuming, because they come in different sizes, E12, 14, and so on. They get bigger and bigger. But these are, I'm pretty sure these are E10. These bulbs are 6.3 volt, 250 milliamps. So that's what that requires. They're all 6.3 volt. Now, what am I going to do with this lamp socket? I'm going to need to fix it somehow. I'm thinking I could maybe put a little tiny screw through there because these insulators are going to fall off. I might have to put a little tiny screw through and hold this lug on, and I think that might hold. Other than that, I might have to solder something together. So let me remove this lamp from the circuit. I don't know if I can do this easily or not. And we'll have to piece this back together so we can use it. See, it's already getting loose. Alright, so I scrounged up some hardware. What I got here is a, looks like it's probably a M1.6, and then I got a little brass nut that fits on it. So this will bond everything back together. Let's see if this will work. It's a Torx. It's a T6 Torx, so let's try this. Now what I did is I went inside here and I flipped up the little flap. There's a little copper flap that lays down, and I bent it up to expose the hole in the center. So I'm just going to put this, I wonder, I need a pair of tweezers, I think. Let's try and see if this fits in the... And then we're just going to crank it through. I don't care if it fits or not, it's going to go... It's getting tighter. This might be M7, let me see, or T7. T7. Yeah, it fits a little better. This thing is getting tight. Once we get it through, okay, it bottomed out. Let me see. Okay, so we have quite a bit of thread showing. I'll put this threaded insert on. Perfect. This is going to work. If I can find needle nose, I can tighten this down. And snug it up good. Okay. Now I just need to flip this flap down over the screw head. And that'll be our button connection. Okay. Got our lamp. Let's test this. Okay, switching on. Perfect. Except I have this upside down somehow. How did I do that? Oh, that swings around. Turn the power off while I do this. Okay, we are back in business. And that's what it looks like with 4 lamps installed. Now you got bright, dim, bright, dim, bright, dim, bright, dim. That's why I'm not a big fan of these LEDs. They kind of don't give even light. What should happen is we should put another, maybe another diffuser behind there. It might split that light up some more. Alright, I'm going after the dial pointer lamp. Now this is a little tricky. This dial pointer here is pretty flimsy and it's not really constructed very well. The way you're supposed to remove this is with no string. You slide it off the end, right? But we don't have, I'm not going to disconnect the string or the dial cord. But to get this off, you need to slide this past this point. But what I'm going to do is I'm just going to leave it in place. What I did is I bent this side open. I don't know if you can see that. I just went in here with this little screwdriver and bent this side open a little bit. We're just going to remove the lamp, this clamp here, lift that up a little. And then I should be able to just pull this out with, oh, it's glued in or something. I see, this might be difficult. It is not budging. I wanted to get away from just taking the whole thing apart. Let me see if I can get this to move. This is all fragile here. I don't want to bend it up too much. I'm already bending it up. I'm going to have to straighten it when I'm done. But let's just see if we can get this to pull out. No, it doesn't want to move. Oh boy. Now you have this part here, the silver part, and it's folded over this lip. And it goes down. This is the carrier of the pointer. And then there's a black cover that's crimped on. 1, 2, 3, 4 spots. It's kind of like covering it, and then it's just pinned. I'm going to see if I can remove this. Okay, I'm not particularly pleased with the design of this lamp arrangement. So they got it in a little metal box. It's covered with a metal cover, and I think it has like a rubber insert that holds the bulb in place. So what I did is I opened up this back part of the box. I opened the flap up quite a ways. You can see it here. It's opened up. I just did that with this needle nose pliers, and I'm just going to pull the bulb out straight out the back without trying to bend anything. So I'm just going to grab it with the pliers to secure that, and I think I can pull it out, and I did. Not great. You can put that back together and then just put that flap. So let's, what is this? This is 8 volt, 50 milliamps. You can see that on there. It says 8V 0.05A. So this will go in a lot easier. This will actually fit into the cavity. But you just can't fold the wires up because the resistors, you can't just fold the resistor in half. It doesn't work. They like to break. So I think this won't go as far in, and I think we need to fold this up. We need to fold this up better so that the wires come out the top. Let me put a fold right about. It's going to play tough, is it? Right about there. And that can go back in. And it goes through the cutout for the wires. Alright, so let's do something with this. Let's wire it in and see how it works. This bulb here. See, the problem is these wires are not very long. They're only about 7 inches long. So let me put this back in. I hope there's enough light inside there to flood and illuminate the dial pointer. So let's close this flap. There. That LED is in there now. And let's pin this down. That's good. That's good. Okay, our wires. I'm wondering if I make the joint back here, whether there'd be enough wire to. Oh yeah. So I'll make the splice back here on this this carrier. You can't even see. I'm way out of frame here. Okay. Yeah, I'm thinking of making the splice back here. These wires are long enough to reach. Wires are definitely long enough to reach. Make the splice here. So let's cut this off. And then we'll make our splice, get my iron warmed up, and then we'll see how this holds together. If we have to make any adjustments, we will. Let me take this little this on. Put that under here, just to protect the wires. I don't know. They're not going to get cut, but just to protect them and hold them down. Okay. I think I want to do is straighten out my needle now, because my needle is a little twisted. So straighten that out. That's good. Go back and forth. Make sure it's good. Okay. Let's make a splice, and then we'll come back and see how it looks. Now, this is 6.3 volts AC, and we're lighting up the LED with AC voltage, so there's no need for worry about polarity. The lamp is going to strobe. Nothing you can do about that, other than build a little circuit or tap off a DC supply, which is typically what I do when I do LED retrofits. Is I tap off a DC supply, or I make a little DC power supply to supply the current for the bulbs, the LEDs. But we're just going to go, we're installing the kit, so that's what we're doing. We're installing a kit. So I should have actually wrapped these up. I can still do it. You know what? I lost my little piece of heat shrink on the end here. Where did it go? I have to do this again. Take this off. Where did the heat shrink go? It fell off. Oh, there it is. One here. And one here. It keeps falling off. Okay, let's do this. Should I wrap this? Let's solder that one. Solder this one. Okay. And your heat shrinks. Okay. Let's attach this. Attach this. Alright. See how that looks. Okay, let's turn it on. And our LED is working. Looks pretty good. I think it's all right. Okay, so we're done with this. I'm going to clean up inside here. There's dust, and there is dust on the face. So I'm going to clean all this up, clean up the glass, put it all back together. Next thing I need to do is install 2 fuses. these fuses are in line with the power feed for each power amplifier. I haven't put those in yet. So we're going to put that in, we're going to set up the bias, and then we're going to finish this thing off. Okay, first power up for the power amps. Fuses are in. Let's turn it on. Went up to about 17 watts. It's dropping back down to about 7.5. Damn.
Are calmer. All 17 homes that evacuated are currently safe. We do have
AM's not working that great.
and we haven't had any damage.
Let's see what FM does.
It's Bree on the Bear.
If you've been trying to win tickets to the Kings of Leon today,
It's working good.
Medley, and when you do, and it says call 9.
Got both channels working great. Okay, I think
17B travel trailer. But once again, Monday through Fridays, you and I get a weekend.
bass treble's
So does
working.
Get Set for summer.
It ain't 'cause of my truck.
Okay, we're looking good. So let's set this amplifier up and then we'll do a test. Alright, so this is a manual. Actually, this is the schematic. There's two pieces to this this information. One of them is a manual, which is kind of like an owner's manual slash how to do an alignment. And then the other one is the schematic itself. They're separate documents. But I'm trying to figure out what's going on here. So this is our output devices, these four, and our emitter resistors, these four. Now, they have here, this is the power feed from the power supply. Pin 2 goes through our bulk capacitor, 1000 microfarad, 50 volts. That's now 2200. Goes through here. And it says it should be 80 milliamps at idle. And it says here 1.2 amps. That's full power. 1.2 amps full power, 80 milliamps idle. And then it goes through the two fuses, okay, F2 and F3, both 1 amp, and then it goes to the output devices. Now, 80 milliamps total means 40 milliamps for each channel. So we should be able to measure 40 milliamps across one of these resistors. And actually it'll be less than 40 milliamps because I think pin 3, see, pin 3 goes into this board and pin 3 goes into this board. I think there's going to be other components sucking power too. So if I go up here, you can see it. It's at the top here. Here's pin 3 way up top comes in. This is the driver complement. And that's it. This is a blocking capacitor there. So this leg here is going to draw current as well. We could figure out it's a 220 ohm resistor, 22 ohm, 220 ohm resistor. So we could calculate the current through there. It's not going to be 40 milliamps, that's for sure. It's going to be a lot less. So let's go back up here and let's look at this. So 40 milliamps on this one, 40 milliamps on this. We can measure these emitter resistors to see what it is. This pin 7 should be somewhere around 17 to 20 volts. And then this capacitor blocks the DC before it goes, the audio goes to the speaker. That's how all that works. And this manual is not really clear on how to set this thing up. So I'm going to go and check our current on these resistors, and then I'm going to check the center point voltage, and I'm going to see if we can adjust it, and then we'll figure it out. Alright, let's see what we can do here. Let's check our center points first. I'm going to connect one lead to ground chassis. And the other points are right here and here for the where the capacitors connect to. So this should have voltage. The other side of the capacitor should have 0 volts. So let's connect this side up first. Where can I connect this? I think right here. Alright, and you can see that. Let's turn it on. Turn this down a bit. So we got about 18.8 volts total on the center point. Let's check our rail voltage first so we know what that is. So let's go over here. Check this on the main capacitor. 40.27. Okay, we should write that down because we need to remember that number. Okay, 40.2, no load. Turn it up. It'll start dropping, okay? So let's go here. This is our first center point. 18.7. Other channel. 18.4. Okay, let's measure our voltage drop across one of these emitter resistors. Let's go here first. If I can do this without shorting everything out. Okay, millivolts. So we got 13, 17.4, 5. That's probably about right for bias. I think that's good. Let's check the other side. Let's go down here. Gotta be careful, there's a power switch here with 120 volts. I don't want to zap myself again. And then we got 16.25, 16.3. Okay, that's good. Let's connect up our ground again. And our midpoint. $18.6. I'm just trying to figure out which trim pot adjusts which side. Okay, that's the other side. This side here. Let's try adjusting it. We want it close to 20 volts. Well, that is not changing anything. Is it changing our bias current though? Let's connect this and see. It is. Okay, we don't want too much bias. I think it was good right around 17. So maybe I'll set them both to 17. We could even test this when we put a signal to it. We can turn it down until we get distortion, and then we can turn it back up until the distortion disappears. But then we have to measure distortion somehow. But let's just set this at 17, let it idle for 10 minutes, and then we'll come back and check it again. This is going to float around a bit. Let's try the other channel. $15, a little low. So I guess these trim pots do adjust bias, not the center point. 17, there we go. There we go. Let's check our center point again. What do we got here? 18.5, 18.3. Pretty good. I'm going to leave that for now. Okay, so let's do a quick power test here. I'm not going to do maybe the full 10 minutes, but we're going to see what this can do. Oh, it was turned on. Turn this off. Okay, so we have everything connected. I got my load, voltmeter, scope, timer all set up. And you should be able to see the scope on the screen. Let's turn this to auxiliary. And I think I have my tone already set up. Now, that should be the load. So let's turn this up. Or maybe not. What is this? Where's my speaker switches? Working blind here. Okay. There we go. That's what I wanted to flip. We got our two signals. Okay, 1000 hertz tone. Turning it up. Oh, it's actually not too bad. Let's give it a little more. Turn my probes to 10 times. Okay. Turn this up to clipping. There's our clipping. Okay, right there. And we have 9.58 volts RMS on the output, on the left channel. Actually, the right channel wants to clip a bit. I'm going to turn it down a little. .98 volts RMS. Thing I want to do is I want to measure rail voltage at full load. So let me spin this around a bit. And our rail voltage is right here. 34.3. We are consuming 49 watts total at full power. So it's not a big powerhouse, that's for sure. Nice little unit for, doing everyday daily driving. Listen every day, all day long. If you're going to listen to music, it's a nice little unit. Consumes very little power. Now we're 6 minutes in, and this thing's getting a little warm. It's reading 40 degrees, but you know what? It is a lot higher than 40 degrees. This cheap thermometer is not picking up the true temperature. I think it's reflecting it a little bit. Right there is 40. That transistor's 42. That one says 27. I don't believe that. These are a lot warmer than 27, that's for sure. It's more closer to 50. It's not too bad, considering it doesn't have any heatsink whatsoever. They're just using the steel chassis as your heatsink. It's not bad, I guess. But we got 7 minutes here at full power. Hasn't blown up yet. I think I'm gonna just let this test end here, and we'll maybe look at some square wave. Okay, so here we got 1000 hertz square wave. I'm playing with the tone controls right now. This is bass cut, bass boost. It's pretty normal. Where's the other one? Treble cut. And treble boost. Quite a bit of boost on the treble. I'm going to set it to the midpoint. Not the greatest sine or square wave, but then you got to remember we got capacitor outputs. So I'm going to go up in frequency. Let's do this. Where are we at now? 4 kilohertz. Let's go up higher. 5, 6, 7, 8, 9, 10. 10 kilohertz square wave. Pretty slow rise time on these. Let's see the overall effect of the treble control. Okay, I'm going to leave it at that. Well, there it is, all back together. Looking really good again. It's actually a very, very nice condition Pioneer receiver. It's never been worked on before, besides me. I didn't see any evidence of anybody in here before me. It had all the original lamps and you know, original capacitors. They're all gone now, but it was really nicely kept example of a Pioneer receiver from the early 70s, I think. Yeah, and it's gonna live on. So let's have a little listen.
Listen to this program, I do upload it to mixcloud.com/jazzology, CJSR, all one word.
La dernière gifle de tout. OK, on n'a pas de choix.
It's giving the deal, quote, serious scrutiny. It's one...
Find the full schedule at wildroseshows.ca.
There any funding available while...
Lots of stations picking everything up just great.
To present every mother you care about.
It's quite selective and it's quite sensitive too. Sounds good. You got to really find the center point of your tuning when you're doing this, but that's what early tuners were all about, is get the station tuned in properly.
Hit number 2, Big Daddy.
I feel like we need further away.
Pull.
Be nicer if they had a bigger meter. It's all there. Okay, well there it is, it's finished. I'm going to enjoy listening to this one for a little bit, and we're going to see how it sounds. The big story for this one really wasn't anything. This is a shelf queen, and it really didn't need any work. Capacitors were still formed and doing their job, even though they were all out of spec and all the tolerance. I really didn't find any bad capacitors like I normally typically do. They were all there and they were all doing their job. They were high in value, which means they were leaking, internal leakage, and they had, you know, slipping ESR and stuff, but they were still holding up pretty good. The other big story about this was lamps. All the original lamps, half of them were burned out, so we put an LED retrofit kit in here. Had the wrong fuses in here, so we replaced those, and that was it. There was nothing wrong with it otherwise. I didn't touch the potentiometers, didn't touch the switches because they were all working. I think somebody's been in here maybe servicing those switches and pots before, but it's working, and I don't have any scratchiness or whatsoever, and they're cutting out or anything. The big downfall for this one is the wooden case. Now this would really benefit from an application of Danish oil or some other treatment. I know some of you other guys like doing different things, but you know, this wooden case, it's a real wood veneer. It does need some help. Now he said he was either gonna get a new cover made for it or do something. This one would actually respond to just a really light sanding and a refinish. And yeah, because there is some nasty scratches on top here, and it is really dry, like it sat in the sun and baked for decades. But yeah, I'm gonna get it back to the owner. I'd be happy to get it back. And I really enjoyed working on this one. This is you know, this is one of the first early Pioneers I worked on, so it was a good learning experience for me. Wasn't impressed with how they do the wiring, like the early Harman Kardons. They don't wire them properly. They don't follow the star ground topology, and have ample wiring for the power, the speaker, and the grounds. You know, like we did for some of the other older ones. This thing could use a star ground or retrofit, and I didn't do it. I just left it alone. I think it's okay the way it is, but it is a low power receiver, and it's not gonna rattle your windows very much. But yeah, well, thanks for watching. I got lots of cool stuff coming up, and I hope you stay tuned, and we'll see you on the next one. Take care.